Today we're going to talk about momentum and conservation. This is chapter 9 in your textbook. So a couple things I want to remind you guys about. Newton's second law, this is pretty key, and so we're going to use this again. And so I just wanted to give it to you guys here to remind you. Again, force is measured in newtons, which I know you guys know, and that your acceleration depends on your force and your mass. This is going to be really important when we start talking about momentum. One of the important key concepts in this chapter is impulse. And impulse is your force multiplied by your time. We're going to do impulse is measured in newtons per second, and we're going to be able to figure out the impulse of a baseball or a car or any sort of crash. And so this will be kind of important. But you just need to know that impulse is equal to force times the time. Now, momentum is our big equation in this chapter. It's not super difficult, but it is important. So momentum is measured in kilograms per meters per second, so it doesn't have a really nice unit, which is kind of sad. And then momentum, for some reason, is this little p, and it's actually a not an American p, it's a Greek letter. But it looks like a p, so you can just draw a p, and it's just your mass times your velocity. And so we use P for momentum, which is kind of confusing, but make sure you get that straight in your heads. The impulse momentum theorem, this means that impulse, that force times distance that we talked about earlier, that means that is equal to your change in momentum, or your final momentum minus your initial. So momentum is mass times velocity, so it would be your mass times your final velocity minus your mass and your initial velocity. Okay, this is kind of what goes on when we talk about airbags. Airbags reduce the force on you by hitting the steering wheel by exerting the force over a larger area, that big giant airbag, and reducing your likelihood of injuries. And so this is really some key concepts when we're talking about car crashes and things like that. Okay, now let's try and solve this.